All right, next thing we're going to cover is some of the more details of how you control figure size, aspect ratio, and dots per inch. So when you create the figure, either using this PLT figure, or our preference is to use the subplots because of all of the functionality it gives you, is to set figure size at that point. So you can set fig size, which is, I believe by default it's in units inches, but that can be changed. And then you can set the resolution. Typically you don't need to change the resolution, but it's possible. So this would be 12 wide by 3 tall. So it's always in the standard kind of width by height, or rows by column sort of thing. Now to save a figure, this is a method of the figure object or the figure class, and so we say fig, or whatever we called this thing, right? We called it fig, so we're going to use that dot save fig, and then you can call it whatever you want. And this path can be, this is right now it's just a relative path, so it's going to save it in our current directory, but you could specify the full path that wherever you want that to be saved. It doesn't have to be in the present directory, right? And then the extension that you use will be the extension of that it uses. So it knows if you type, I want this figure.pdf, that it'll create a PDF or PNG, etc. So it can figure that out. So whichever you prefer. I find PDF is really flexible, but in some cases you might want something else. You could do PNG with specifying the resolution. And then if we go to our, if we go back to this tab here, you can see we now have these myplot. So let's see, hopefully these will show up in, okay, the PDF is not showing up in the browser. PNG does show up. Those are both, the files are fine, it's just what works in the browser. So you can quickly preview that and you can see that it's there. All right. So it lists the formats here, and if you use LaTeX, for example, it works really nicely with PDF. So that's another good reason to use PDF. One other, well, I'll come back to this. Yeah. Okay. So the next step is legends, labels, and titles. So this is an object or a method on the axes rather than the figure. So to set the title, you would do ax.setTitle. And to do axes labels, you do set x label or set y label. And then to set the legend, you can specify a list which would correspond to the different categories. So let's see. I think we have an example below where we combine everything, although we're not seeing the output here, which is frustrating. So when you create that legend, you also have control over where it goes using this loc function, or this loc parameter. So you can set it to 0, which lets matplotlib decide, 1, which is upper right, 2 upper left, 3 lower left, and 4 lower right. So here's an example where we can see it all together. So first we're creating this figure using subplots. We just have one subplot because we didn't specify any dimensions here. So we have, on that axis, we're going to make plot. And one of the cool things about the legend is if you specify the label that you want to use when you create that plot, it will use that when you create the legend. So here we didn't have to specify this vector of names because we specified it in the individual lines that we created. So we created two separate lines on the same axes, and then we created a legend. We turned the frame off so we don't see a frame, although we can set that to true, and then we'd see a frame around there. And then setting the X and Y label and the title. If we want to add some more fancy formatting, we can use Latex Style formatting. So here we can use things like alpha and exponents and a number of functionality from using the LaTeX style is supported. So to do that, you'll want to use this R before the string. Remember, that's the raw format, so that prevents things from getting interpreted in different ways. It'll just preserve that string as you typed it, and then it will then interpret it later as a LaTeX string. Some other things we can do is we can specify the fonts of these things as we type them. Like here we have font size equals 18. But we can also set a global font size using this command matplotlib rc_params update, and we can set the font size and the font family. And there's even, you can, I think scripts requires like you to use Times New Roman in your thesis, so you can, there's a way you can get Times New Roman for everything. So here we've changed the font size to 18 for everything, and we've changed the font family to serif. So if you like that style, then that's an option. So here's another way to do it using this sticks font family. And then this example will use tech throughout. So the nice thing about this is that all of your fonts will have the same font. All of your text will have the same font, so it looks nice. And here you can now we're going to restore it back to the defaults. So everything else now will look like it did in the beginning. Okay. So there's a number of other things we can format in terms of colors, line widths, line types. Here we're going to make subplots, and we're going to create two lines. One, a blue line with dots, and here is going to be a green dashed line. So this uses, if you're familiar with MATLAB, this uses similar kind of syntax as MATLAB. There's a number of ways to specify colors. We're going to see a lot more when we do the Seaborn examples. But you can specify, basic color words. Say red, for example. You can also set the alpha, which controls the transparency. You can also use RGB hex codes for different colors. So you can have a lot of control over the colors here. There's also the ability to control line and marker styles. So in this example, we're going to see a lot of stuff. So we're going to make subplots here, and actually it's just going to be one plot, but we're going to have a bunch of different lines. So let's have a look at the output here. So we've got different blue lines here with different line widths. So in this first example, we're controlling the line width. In the next example here, we're changing different line style options. So we've got dot, dash, all dots, larger dashes, etc. We can also change here the marker style. So in fact, in these first few, we didn't have a marker. If we want to see a marker where our data points are, we can set a marker to be like a plus or a circle, a square, or a I guess this is another kind of square. And then we can also control the we can simultaneously control marker size and color. So there's a lot of different options here for customizing our lines.
I have a quick question.
Mm-hmm.
Just go up a little bit. You have a comma after line. Is that like right up there? Is that like storing? Is like a method to nothing, or is it not making a difference?
Yeah, that's a great question. This one, yeah, I didn't write this example, so let's see what happens if we remove it. It doesn't work. Okay, I'll have to look that up. That's a good call. Yeah, let me come back to that. So there's a few other options. So we saw before how you can do the tight layout. There's another option called axes tight, which will kind of change how the graph is rendered. We can also change the x limb and the y limb. Yeah, the tight doesn't seem to do a lot on here, but at least in this example. But you can see the setting the range gives you the ability to have some control over how it's rendered. We can also do logarithmic scale. So you can use this command set y scale or set x scale log, and this again, this is a property of the axes rather than the figure. So here we have a figure and two axes. So here, remember earlier in the class we said that you have these arguments that can either be positional or keyword arguments. So this is we can just have a look here. So this is the number of rows and this is the number of columns. That we could have written n rows, n calls, but we just wrote 1 and 2 and it knows what we mean here. And then the third argument is going to be figure size. So the whole figure is going to be 10 by 4. And then so then we're plotting the same data in both plots, but in the second subplot we're setting the y scale to logarithmic. So we can see how that changes the way it appears. So another thing we often want to do is change where the ticks are and what the labels are. So we can use these commands set x ticks and set x tick labels. Again, these are properties of the axes. And we can do set y ticks and set y tick labels. So here we're going to set, the other thing that we're doing here is we've got two different plots, and so if we put, if we want, I don't typically do this, but you can put multiple x and y coordinates after one another. So this would be x, y, and these would be two different series. And then we're going to change the X tick and Y tick labels. So in the, and let me, okay, that's fine. So what we're doing here is we're saying on the X axis we're going to set the ticks to 1, 2, 3, 4, 5, and then name those. And they just the vector that we use, these both take lists. So this is the list of the coordinates of the X ticks, and this is a list of the labels. In this case, we're going to use Latex Style Greek letters, and those will go in the same positions as the ticks. And then we can, in the Y, we can do the same thing. And here we're creating a variable that holds those values, and then we use that to set the Y ticks. And then we are using this string formatter method with LaTeX formatting, so we use the dollar signs. And in that we're getting the first decimal place of those values. So you could imagine an example where you had say smaller values that you wanted to be able to see the just that one decimal point. So we can also do scientific notation in our ticks. So what we've done here is there's some extra. Typically this can be handled automatically, but if it's not, there's a way to do that that's listed here. So we can set, say, the y-axis to have scientific notation using this formatter.